Section 3.3, proving lines parallel. Theorem 3.4, the converse of the corresponding angles theorem states that if two lines in a transversal form corresponding angles that are congruent, then the lines are parallel. So if you can prove congruent corresponding angles, you know that the two lines that they were created by are parallel. The converse of the alternate interior angles theorem states that if two lines in a transversal form alternate interior angles that are congruent, then the lines are parallel. So just like the corresponding angles theorem, if you have two alternate interior angles that are congruent, then you can prove that the lines that encompass them are parallel. So first question here, which lines are parallel if 1 and 2 are congruent? So angle 1 and angle 2. Well, those are corresponding angles. And if those two lines are corresponding, those two angles are corresponding, this must be our transversal. So that means our parallel lines are going to be line A is parallel to B. And we know this because of the converse of the corresponding angles theorem. Question B, it says, which lines are parallel if angles 1 and 4 are congruent? So 1 is here, 4 is here. If that's the case, that means line A is our transversal, so our parallel lines are going to be L and M. So L is parallel to M by the converse of the alternate interior angles theorem. Question C, can we determine parallel lines if angle 8 is 105 and angle 5 is 105? So basically, if this angle and this angle are the same measure, which makes them congruent, can we determine parallel lines? Well, yeah, because that means this is our transversal, those are corresponding angles, so that means L and M must be parallel by the converse of corresponding angles theorem. Anytime you're proving parallel lines, you're going to use the term converse. If you haven't noticed now that all of our theorems proving parallel lines deal with the term converse, anytime you're proving that two lines are parallel, you're dealing with the term converse. Question D, can we determine parallel lines if angle 5 is 98 and angle 3 is 98? Well, angle 3 is here, angle 5 is here. In reality, no, we can't, because these are actually just vertical angles. There's not much we're going to be able to do with these two other than say they're congruent. So nope, these are just vertical angles. Theorem 3.6, the converse of the same side interior angles postulate. So once again, converse means we're proving some lines parallel. So let's see what this says. If two lines in a transversal form same side interior angles that are supplementary, then the two lines are parallel. So if you can show that two same side interior angles are supplementary, then you know that the lines that they're sandwiched between are parallel. Theorem 3.7, converse of the alternate exterior angle theorem, states that if two lines in a transversal form alternate exterior angles that are congruent, then your lines have to be parallel. So if you can show that the two alternate exterior angles are congruent, then the lines that they're created by must be parallel. Here it wants us to determine which lines or segments are parallel and justify our answer. So if we look carefully here, we've got congruent angle here and congruent angle here. If we assume they're laying on the same transversal T here, that means we have alternate exterior angles, and then Q must be parallel to S. So line Q is parallel to line S by the converse of the alternate exterior angles theorem. In question 2, We've got the markings for parallel, so that's pretty straightforward. But we should also notice that we've got 112 and 68 here, that when added together, those two angles make 180. So if these are our lines here, and this is a transversal, those two angles are same side interior. So that means for us, we can say that K is parallel to P, or KP is parallel to MN by the converse of same side interior angles theorem. We can also say, in this case, that JQ is parallel to MN based on the symbols as well. So these two are marked. That's where we get this one from. And we know that these two are parallel because the two angles here are supplementary. So the two lines here create same side interior angles that are supplementary. All right, here we are given that angle 4 is congruent to angle 6. We want to prove that L is parallel to M without using theorem 3.5. So first step, we're going to state the given. So angle 4 is congruent to angle 6 by the given. Step 2, I should notice that angle 4 and angle 2 are congruent because they're vertical angles. So I can go that route. We'll try to see if that connects to anything. Well, notice that 6 and 2 are both congruent to angle 4, so chances are we can then say that those two are congruent by the transitive property. And then if 4 and 6 are, or 2 and 6 are congruent, if 2 and 6 are congruent, that means we have corresponding angles that are congruent, so that tells us that our lines must be parallel by the converse of corresponding angles theorem. And sure, we could have proved this a lot faster using the converse of the alternate interior angles theorem, but it asked us not to use 3.5, which is that exact theorem. This time we're given that angle 5 equals 40 and angle 2 equals 140. We are asked to prove that A is parallel to B. First step, we're going to state the given. So angle 5 equals 40. Measuring angle 2 equals 140. And that's the given. So 5 and 2. When you add them together, you get 180. So we know the measure of angle 2 plus the measure of angle 5 equals 180. That's just angle addition. From there, because we know they add up to 180, we know that angle 2 and angle 5 are supplementary. And that's by the definition of supplementary. We have two angles that add up to be 180. And so if those two angles are supplementary, in this case basically being same side interior angles, we should be able to prove that our two lines are parallel. So A is parallel to B by the converse of same side interior angles. This time we're told that 1 and 3 are supplementary, and we've been asked to prove that A is parallel to B. So first step, we're going to state the given. So 1 and 3 are supplementary, and that's just by the given. From there, I should also notice that 1 and 2 are supplementary because they form a linear pair. So 1 and 2 are supplementary, and this is by definition of linear pair. At this point, I should notice that angles 3 and angles 2 are both supplementary to the same angle. Therefore, they must be congruent by the congruent supplements theorem. And if angle 2 and 3 are congruent, those are corresponding angles. So if those are congruent corresponding angles, that tells us that A is parallel to B by the converse of corresponding angles theorem. In this problem, it tells us that we are given angles 2 and 8 are supplementary, and they've asked us to prove that L is parallel to M. Well, first step, we're going to state the given. From this, I go, okay, I've got 2 and 8, so I've got dots here. I should also notice that 2 and 4 are also supplementary because they're a linear pair, so I'm going to go that route. Oh, and in this case, I mean 1 and 2, not 2 and 4. 1 and 2 also are supplementary by the same reason. So 1 and 2 are supplementary because they are a linear pair. So right now I've got this angle and this angle were supplementary. Now I've proven that 1 and 2 are supplementary. But at this point, I should notice that angle 2 is supplementary to 8 and angle 2 is supplementary to 1. So if these two angles are supplementary to the same angle, they must be congruent. So 1 is congruent to 8 by the congruent supplements theorem again. And in this case, if 1 is congruent to 8, we've got alternate exterior angles, so we can say that L is parallel to M by the converse of alternate exterior angles theorem. All right, in this example, they've asked us to find the value of x for which A is parallel to B. So we're assuming the two lines are parallel, which means these would be alternate exterior angles. So they would be congruent naturally. So to solve this, we're going to take 6x plus 17 equals 143. And then we're just going to solve this algebraically. So we'll subtract over the 17. I've got 6x equals 126. I'll divide by 6, and I get x to be 21. Here, for which values of x is A parallel to B? So once again, we assume the lines are parallel, so that means these two angles are same side interior, so that means they add up to be 180. So we've got 65 plus x plus 72 equals 180. We'll go ahead and combine like terms. We get x plus 137 equals 180. I'll subtract 137, and I get x equals 43. Last but not least, we want to do the same thing here. They're assuming A and B are parallel, which makes these two angles corresponding, or in this case, they'd be congruent. So 7x plus 2 equals 8x minus 14. Let's get our x's on one side. We'll subtract 7x from both sides. So I got x minus 14 equals 2. Then I'll add 14 to the other side, and I get x equals 16.